All right, guys. Let me just warn you that I am an engineer by nature, and I prepared my own slide deck, and they are not that fancy, and they are a little bit complicated. So just cautioning you that you have to bear with me for the next 20 minutes. Now, let me also answer the question by basically starting this question that why Wi-Fi 8 now? Because I get asked this question by many, because looking at the work that we are doing with the Wi-Fi 7, WBA actually is about to wrap up the Wi-Fi 7 trials, and we see the Wi-Fi 7 deployments picking up. Now, basically bringing the Wi-Fi 8 to the question over here basically freaks out quite a few people around, say that, do we have to make another investment? Do we have to do this, etc.? What is new with Wi-Fi 8? Because looking at the result with the Wi-Fi 7, we have now 1200 megahertz channel or spectrum available with 6 gigahertz, as well as we have enabled multi-link operations. We have 4K COM, and these are really amazing capabilities that basically we are already delivering. And looking at the results again from the WBA side, we easily achieved 3.5 gigabit per second throughput for downlink, and as well as close to it for uplink. Given these amazing numbers over here, the question always, what is more? What is more Wi-Fi 8 can offer? What Wi-Fi 8 actually can bring to the table that basically we should be interested in? These are the questions that I'm going to basically try to share with you in terms of what is happening in the Wi-Fi 8 and why we are looking at in this space and what it is in terms of those areas. Now, looking at the work that is taking place in IEEE 802.11bn, BN is the task group that was basically named as Ultra-High Reliability Wi-Fi. Ultra-High Reliability, UHR, is the name basically that communicates what Wi-Fi 8 is trying to achieve. Bringing the reliability, bringing the basically the efficiency, bringing this better experiences to the Wi-Fi space as part of the next generation work that we are trying to do. Now, going from here, basically, let me just see, is it working? Which one is working? It's going back. Okay, now I figured that out. Now, looking at the generations of the Wi-Fi, basically, especially in the last few generations, Wi-Fi basically has gone through the step functions. Basically, in the one step, we just look at the increasing the throughput, and then we just look at the next step, increasing the efficiency and reliability. Starting with Wi-Fi 5, basically the name of the Wi-Fi 5 in the standard called HT, 802.11ac, HT, high throughput. It enabled basically 5 gigahertz, and with the 160 megahertz channels, basically we enable that one. We move to Wi-Fi 6. The name of the standard is called High Efficiency Wireless, HEW. Basically, that's the step function from high throughput to efficiency. Now we went to Wi-Fi 7, extreme high throughput, EHT. That's the name of the standard again. Step function is to increase the throughput with the additional 1200 megahertz channels or spectrum that is available, and 320 megahertz channels and all that stuff. It is just basically extreme high throughput in reality and in truth. Now with the Wi-Fi 8, again, the step function is to increase the ultra-high reliability, efficiency, and experiences, so that we just go through this 4-year cadence to improve the throughput and improve the efficiency, improve the throughput, improve the efficiency. Right now we are at this cycle over here. Now, going from here, basically, looking at what is happening with the Wi-Fi 8, what are the things that is going to help us with the efficiency? Now, I should bring it to your notice that last week actually was the IEEE week. I have some of the colleagues in the room who were at the IEEE week discussing Wi-Fi 8 throughout the entire week. And finally, basically, we are at the point where we can just look at these key capabilities, what is being discussed and agreed upon on the Wi-Fi 8. There are a rich set of these capabilities. I try to capture some of them. Basically, those are, one is the multi-AP coordination. This is one of the key capability that is going to basically define and drive other surrounding abilities or features, like the one over here, coordinate. Basically, the name of the game over here is becoming coordination. Coordination, basically, how you can basically get these devices coordinate with each other to perform efficiently and effectively and reliably so that we can enable these experiences, better experiences. Now, looking at this multi-AP coordination, basically fits into coordinated roaming, coordinated special reuse, coordinated beamforming, coordinated TDMA time sharing, coordinated RTWT. These are more technical things. And there's also a dynamism aspect of the things. Now, we are talking about the dynamic power save, dynamic sub-channel operations, distributed resource unit, non-primary channel access. The list goes on and on. So this is the long list people at IEEE 802.11bn currently discussing. And, to a great extent, at least, we have reached an agreement to consider these items within the work of the 11bn. Now, what are these things are going to ultimately give us too? These are basically going to give us the really better user experience, spectrum efficiency, power saving, connection density, where we can connect more devices to the AP or then deploy more APs in a given location so that they can basically coordinate and work together better. And really, make the best out of the spectrum, which is the precious asset we have, and to our best. And at the end of this thing, basically, just to make the best out of the Wi-Fi resources, put it into use versus to currently, we have large bandwidth and spectrum available, but given the nature of the space that we operate, we see that that there are lots of devices are coming into the spectrum, and so many unique use cases are being enabled. Given all these and these basically, we are looking at how we can just really advance in the future growth into the space. Now, moving from here to question over here, why? Right? Why, IEEE or the industry is actually talking about this early? Because again, the question, we just are deploying the Wi-Fi 7 right now. Why right now also think about Wi-Fi 8? The work actually on 11bn or this Wi-Fi 8 has started more than 2 years ago. Basically, as part of the IEEE process, first, we just formed the study group. And study group looks at the use cases, key requirements, and others over there, entertain the discussion as to what the scope of work should be. And this study group was formed back in September 2022, more than 2 years ago. And then we basically approved the PAR. PAR is the one that basically defines the scope of the program project itself back in July 2023. Now, since then, we have formed the task group. Task group started looking at the actually submissions and contributions about the key capabilities, a little bit technical details as to all that stuff. And ultimately, as of last week, again, at the IEEE week, the members or the folks over there agreed on this overall framework of the work that is going to be at least starting the initial draft of the specification, And that's the specification basically, and we agreed on that one, and it will be based, on that agreement and be made available in March of 2025, in 2 months from now. Now, following that, we are going to have the first D1 and draft, basically, 1.0 in May 2025, and the following draft is going to be the May, and the 2.0 is going to be available March 2026. Now, 2.0 is important, where basically the silicon providers pick up the specification with the 2.0 typically and start implementing that on their silicon. And then momentum starts picking up from that point, and it goes with the, I think once the silicon provider enables that one, the Wi-Fi Alliance starts picking up with the certification program, typically about 18 months before the end of the final approval. Time-wise, basically, when we look at over here, the final approval of the specification to take place around early 2028, but the Wi-Fi Alliance most likely is going to pick up the certification program somewhere around mid-2026, and then continue with the whatever the plug test and test events and everything else, make that sure all the pieces work together. So this is how really things aligned. Now, the question over here again is that why we do this Wi-Fi 8 right now from the industry point of view. Again, the question is that the standards basically operate looking forward, not to the moment that we just live in, but we have to look at what is in the pipeline in terms of the technology, in terms of other alternative solution, in terms of all the use cases that is going to be available sometime around 2028, 2029, 2030. That's why we need to start this work, and we need to work on this thing together. It doesn't happen overnight. So that's what we talk about. Wi-Fi 8 is taking place, and that's what we are working with all the industry players to define, to develop this work. This is a lot of work, actually. There are really thousands of brains behind this thing in terms of people directly participating in the IEEE work. There is the other folks behind that and supporting these ideas. Given this, basically, we are aiming all these, and things that are going to be available sometime around 2029, 2030, so that Wi-Fi is going to be ready with all the things happening, including AI, ML, including this AR, VR, XR, and all the cases, because the user experience are becoming more and more important. With the AR or AR, VR headset over there, you cannot really tolerate, extreme delay, less than more than a few milliseconds, because then the users, would just get dizzy. You would not be able to use AR, VR, XR kind of devices. Then the question, how Wi-Fi can ensure that we can deliver bounded delay or bounded latency, and then bring the better determinism into the space. And that's where the focus of Wi-Fi 8, to look at next generation of the devices, next generation of the use cases, where we focus and define and deliver those. Now, going from here, a little bit more technical over here, just to confuse you, maybe, or just, shock you or just lose you. But just to give you a little bit taste of what is coming, basically, one of them is multi-AP coordination. Again, the name of the game is coordination. Previously, with the current generation, typically the APs in this room or AP in many places or devices, they just operate on their own pretty much independently. There is not much mechanism that they can share the information over the air and then basically talk to each other. Without which, basically, then you can do certain things and you cannot do certain things. This multi-AP coordination capability actually was considered as part of the Wi-Fi 7 program itself within 802.11be. Because of the amount of the work, because of all that stuff, it was actually later on deferred to Wi-Fi 8. But this is actually really amazing capability that is going to come. Now the APs and the devices over the air will be able to signal each other, talk to each other. Hey, I am doing this, what you are doing, so that we can basically coordinate and collaborate and then make the better use of the resources and all the things that are available. So that's the red bar over here, or the arrow over there indicates. And now these guys are going to talk to each other to basically deliver better efficiency, better reliability, better of everything that basically the network can do. At the end of the day, we can look at the performance from 2 points. Individual APS performance, you can provide the peak throughput over there, but what is more important is the network performance. When you have multiple APs over here, how much the performance you can extract from overall your network performance versus in many cases that's the case for the operators. That's where the case for many venues over here. So that's where the focus over here is, that network performance, in terms of how you can really efficiently and effectively use the spectrum so that you just increase the performance from the network side again. Now, going from this multi-AP coordination thing, if you just look at the couple areas over here, you can coordinate at the frequency level, where basically you can say, hey, I am using this, and then you are using this. We just basically coordinate sharing the spectrum, and then you can coordinate at the time and time level over there. Hey, I'm doing this, and I have extra time. You do this, so that we coordinate the time-wise. And then you can also do even this coordination at both frequency and the time-wise over there. You can just combine this thing. So these concepts over there brings really amazing metaphor over there in terms of how you can make best out of this, and these network resources in terms of what you can deliver. Now, again, going from this one, this features and multi-AP coordination can be done at the MAC layer or PHY layer. PHY is the more hardware part, including over here really coordinated roaming, which I will just share a slide on that, and then coordinated restricted TWT to bring more reliability or more determinism into your space. There is coordinated in a special reuse, coordinated TDMA, and then at the PHY level, we have the coordinated beamforming, coordinated processing. These are basically the ones that are being looked at and discussed. Again, and they are relying on this concept of coordination. Now, again, a little bit more technical to you guys, but just to lose you or just to get your attention. Now, this coordinated roaming is one of the scenarios. In the current operation of how we do that is that we have two APs, one AP over here, the other AP over here. Between this AP1 and AP2, device basically looks at and scans it around over there. Hey, there is the signal strength over here better. I'm just going to move to this AP. It makes the roaming decision. And when that makes the roaming decision, it just scans and it says, okay, I'm going to move to that one. It just reaches out to that AP. And when it reaches out there, before reaching out to that AP, it just basically tears down the connection with the current AP. And then it moves to another AP, and then it reestablishes the connection with this target AP or new AP. That means that you basically need to also, set up the other, QS, settings and security contexts and other, BA block agreements, and then many other things from scratch. Because you moved from one AP to another AP, you cannot move the context from your current AP to another AP. And processing all these things basically create inefficiencies and, of course, delay in the roaming. And all that stuff comes at a cost. Now with this coordinated roaming, basically what you do, since you can talk to these two APs, you're saying that, okay, now the device, or he can ask this guy over here, hey, what are the other APs that I can connect within this your, whatever the, seamless roaming, the domain. That the current AP now is going to be able to tell, here are the APs that I have around that you can connect and you can choose from. Now device says, okay, I'll just connect to this AP2 in our case. And then it talks to the current AP. The current AP says, okay, it reaches out to AP2, transfer the context in terms of the QoS setting, in terms of the link setting, in terms of the security setting, in terms of the block hacking, all that stuff. They basically goes from one connection to another connection. Then it is, since everything is transition, it becomes really very close to make before break kind of scenario. And since you have already transferred the context over here from one AP to another AP, basically the device moves to another AP almost instantaneously. And the level of what to transfer, whether we are going to transfer the data, what are we going to do for uplink and downlink, those are right now under discussion, as the details are going to be further defined and agreed upon. But the concept over here is going to basically significantly improve the roaming experience and building great efficiencies into the network and our space. Now going from here to the next one over here, the coordinated special reuse. In the case again, and currently this AP over here just basically just blast the power. Another AP is blasting another power, especially in the overlapping BSS, OBSS kind of scenario where you have one home over here, another home over here. Basically, they are just blasting the power. And these are not coordinated with each other. Now it creates interferences. Basically, creating interferences creates really inefficiencies in the airspace. Now, the question is that can we get these APs over there talk to each other so that basically they can reduce their power and then reduce the interference and create inefficiencies, create efficiencies. Basically, with this kind of mechanism, basically without that, and without this coordination, you just maintain your coverage area and huge interferences basically taking place. With this one, now after AP1 and AP2 talk to each other and look at the client space, there's the mechanism and technical details. I will not going to get into it, but at least they can reduce the power. Reducing the power basically minimizes the interference. You create the efficiency over here in the airspace again. Now, going from here, another cool capability is that non-primary channel access. Currently, what we have is that, as it was defined, I think all the way from the time of Wi-Fi 4, that there is the primary first 20 megahertz of the channel, regardless of the channel size. Channel could be 80 megahertz, 160 megahertz, 320 megahertz channel. But if the first 20 megahertz of the channel is occupied by OBSS or there is interference, the rest of the channel cannot be used. Basically, you are wasting tremendous amount of spectrum because that first 20 megahertz is being used by another OBSS or something happens. What happens if you have 160 megahertz channel? You are actually not using 140 megahertz of the channel, wasted. Then the question is that can we use the secondary megahertz and other channels over there where basically you can do the non-primary channel access? Can I have the other parts of the channel, although the first part over here is being used? The question over here is, yes, we will be able to, so that we can basically increase the channel use or spectrum use over here and maximize the throughput and reduce the latency. Again, improving the performance and efficiency over here from the spectrum point of view that is going to help us significantly. there are probably numbers flying around. Some people say that it is going to improve the performance or efficiency 20%, 25%, 15%. But right now, I think we are not going to get into it, but there are going to be significant gains around these key capabilities coming. Now let's go to another one, coordinated beamforming. Beamforming has been in place for many, many years, but it happens over there by per single AP. One AP over there does its own beamforming, the other one does its own beamforming, so that they basically try to do their best with the coordination now. Now I can tell, hey, I have this device over here. I know that one. You just, I'm going to point my beam over here this way, and then the other one, points in when the beam is that way, so that there is this coordination, information sharing. Again, that's going to improve the efficient medium usage in terms of this beamforming. Now, sometimes it works, sometimes it doesn't. Okay. And this is more technical perhaps because it is going one step down. This is basically coordinated TX-op sharing. TX-op basically you grab the medium, and then once you grab the medium, you just have the allocated time period over there. Let's say for every X millisecond. If you say, hey, I use this portion of this and this medium over here, now I can share the remainder part with the other sharing AP. They can basically share the remainder of the time, TX-op time, so that they basically the medium over there is put into use versus to going idle. The sharing mechanism over there can be done at the AP level and at the peer-to-peer level, so that basically you can also bring this peer-to-peer kind of things, because it is becoming more and more important in the dense areas, because right now a lot of people, they have soft APs or hotspot on their phone. They can talk to each other with their device, but at the same time, those peer-to-peer connection competes with the core network or actual network because of the airspace, and it creates interferences and everything else. Now, by basically bringing this kind of mechanism, the devices over the peer-to-peer devices will be able to talk to network. Network is going to tell, okay, go to this in a channel, or here's your TX-op time, so that use that thing efficiently, so that we just try to minimize the interference, and then maximize the efficient use of the spectrum. All right, going from here, this one again, all in all, basically we are bringing only with these capabilities. There are more to go, but I won't. And we are trying to reduce the long tail end of the latency, so that we can actually enable these key use cases that are in the pipeline, including really industrial IoT and this healthcare, in this gaming, AR, VR, and AI ML. Many of these things basically require really more bounded latency that Wi-Fi needs to deliver. And this Wi-Fi 8 basically is going to provide us the path for this bounded latency, where we can enable these key use cases and devices. And lastly, basically, and everybody's talking in eating and breathing AI in these days, and we also have the Wi-Fi, AI/ML program in WBA. We have been asking the question what Wi-Fi can do for AI/ML, and then the other question is what AI/ML can do for Wi-Fi. So this is mutually beneficial, because in many cases AI/ML is going to be transported over Wi-Fi, where Wi-Fi needs to deliver this reliable, efficient way of transferring this AI/ML and data back and forth. And at the same time, what AI/ML can do for Wi-Fi. Right now, basically looking at these amazing capabilities being introduced as part of Wi-Fi 8, basically we are providing additional hooks, additional points where, at the same time, this thing is making the things more dynamic, more interesting, but also bring a little bit more complications in terms of how you can manage all these things, where AI is going to come into place basically by bringing these Wi-Fi 8 capabilities with the Wi-Fi, 8 capabilities with AI/ML. It is going to really help us dealing with these complexities and enable more reliable, more spectrum efficient, more delay-bound determinism, more power saving, and better Wi-Fi experiences. So this is really exciting and interesting in terms of the all in all, really the future is bright for Wi-Fi. And with all the work taking place in the industry, we are continuing to transform the landscape and enabling all these cool needed capabilities with the ultra reliability, reduce interference, improve efficiency, power saving, lower latency. All in all, basically, are coming with Wi-Fi 8. Just lastly, we have the WBA Wi-Fi 8 project. It is basically going to be started sometime in, I think, Q3 or in the second half of this year. We are going to be looking at the key capabilities, what it means from the operators and industry point of view, how they really tie to key use cases, and also engage with the ecosystem, be it IEEE or be it other ones, in terms of just getting the ground going. Now, we would be happy to work with you. If you are interested, please join us when the project kicks off in the second half of this year. That's all I have. Thank you so much. Any questions?
Necati, we have time for one question.
Easy one.
Anyone with any questions for Necati on Wi-Fi 8? Erin?
Easy one.
It might be two parts, but first of all, you talked about the seamless handovers. Will it be vendor agnostic? So if I have a network that's Cisco, Aruba, and Ruckus, as long as they're Wi-Fi 8, will it be vendor agnostic?
I answered to ask the easy question. That's not easy. Well,
Easy answer, maybe?
well, that is up to the vendors. Okay.
Gotcha.
And that is not easy to answer in terms of, I'm not in the AP vendor side. I cannot answer that question, but the vendors are going to do what is good for the vendors. And
So the answer is no.
Most likely, but at least these vendors will just have their APs talk to each other. Most likely, yeah.
Any other questions? Okay, Necati. Thank you so much.
You.
Thank you.